Okay, now we are back. So the next phase of the project or the lab would be to do live classification. So I showed you an example of how do you do, you can sample a test and they will do inferencing on the model that they have trained, as we showed in a previous video. Another way to do it, and we did it by clicking on the start sampling. Another way to do it is using existing data that for your testing and to test it against the model itself. So for example, we are choosing the long press test case that we did earlier, and we are testing it with the model itself, and we have gotten barely passing rate of 0.63. Again, this model is not the best of models, and because it's the lack of data, if you see it's all clumped together. So, and if you can try a few times, you will realize that sometimes your long press doesn't work very well. So that's purely because of the training data, and it got nothing to do with the tools itself. Okay, so let's try another test data for the long press and see how it performs. And again, we barely pass as 0.57. So again, they barely are able to tell the difference. And so in this case, they classify as uncertain because they can't tell whether it is a long press or short press because uh, too close to each other. Okay. So another way to test a model on the cloud itself is under model testing. If you click here and you click classify all, what they will do is they will take all your test data and all the data for testing and the one that you did in sampling under live classification, which I did off screen, and they will do is they will check with all of them and find out what is the accuracy of the thing. So in this case, our accuracy is horrible actually, like 46%. They're able to detect short presses very well, but they are unable to detect long presses. They only have a 22% accuracy and with a 78% uncertainty. So in this case, you are able to use this model to detect short presses, but you're definitely not able to detect long presses using this model. And you will probably have to train more data or find other ways to detect the long press. Okay, so once you are happy with the model, just say that we are happy with this model for whatever reason, you can go to deployment and you can deploy it in the different platforms. In our case, we'll be deploying it at the Arduino library. You click on this guy. If you scroll down, you can actually select either you want quantize or alarm optimize. Choose the quantize so it'll be smaller and more compact, so that you can notice that the flash usage should be smaller than the unoptimized. It's also faster, but accuracy is the same, so it doesn't matter. If you click on the analyze, you'll find out that they will tell you what is the accuracy for either one of them. Once you're happy with it, again, select the quantized version, which is more optimized, click on build. So what's going to happen is that they're going to build a model and they're going to create a library for you, and then you will download it. So in this case, it'll be version 1.03 in my case, because this is the third time I'm downloading this. Take note of two things. First, you have to add the library into the Arduino IDE by clicking Sketch, include library, and add the file. And what is this file? The file that they just downloaded for you. Secondly, you need to download the examples. Okay, so let's get to it. So the file itself is downloaded under downloads. So let's close this. So what happened is that you go to Sketch, include library, add zip, and then it will probably be in your download folder, and you include it in your download folder here. You click on this, and in this case, I had many. This was the most recent one. I click on it, and then you click open. Okay, you're supposed to click open, but in my case, I've done it before. Then what you do is you're supposed to uh, click on File, Examples, and choose the button presser, which is the one that the project we created, and static buffer. then they'll come out with a template. Unfortunately, the template is a little bit more complicated. So what happened is that I created a simpler inferencing code here, and I will send the link to download it in the comments below. Okay, so take a look at the description of the video, and they will give you the link on where to download this code itself. So this code is a very simple code. Again, the main purpose is now each time when you press a button, it will sample the button press for 3 seconds, and based on the pattern of the button press, it will then check with the model which is now in the MSP432. So the model itself is within the MSP432. How does it do that? It will be included in this library. Okay, so the library that you just imported into the project itself includes the model. Okay, and there are a few things that you need to make changes to. One of them is, first you have to set up the button itself. So you need to configure it. You also have to say that how many samples per frame. In our case, there's only one because we only have S1, one sample. Okay, then what do you do is, if you look at the loop here itself, the loop, what does it do? It literally just do a printf and look for, and inform you that it will delay for 2 seconds, then it will start sampling. The sampling will call this function get button, and what does it do? The get button is just a small function here. It will uh, do a tick here, get the data in the button, put it into the buffer, and then update the tick. So ultimately what is happening is that it's trying to get the tick every uh, every few milliseconds. Then after that, it will get the data again. Then after that, get the tick again. So you keep repeating this many times. And it's supposed to be 1,000 times. Okay, so you keep getting the button data. Then after that, update the tick. Then after that, come back again and getting it again, and it will keep doing this for 3 seconds. Okay, so we will get the button data. So if you press the button, you will get a 0. If you let go of the button, it will go to the high. Okay, so then what happens that once you get the data will pass through the model, the classifier, and then it will try to make an analysis of it. So all these things, ultimately you're just passing the data that you obtain into the model itself, the classifier, and it will then print out the predictions, whether there's any anomalies, and the results of the classification itself. Okay, so we can let's download this code here. Wait, hold on. Before you download the code, you will have to stop the data forwarder, because if you have the data forwarder, it's connected to the COM4 and you can't have that. So you do a Control C here to break it. Then you download this code into the Arduino, and this code is now the inferencing code. This will take a little bit of time if you're doing it for the first time. Again, make sure that you chose the right board manager, the right board and the right COM ports. Okay, once you wait, hold on. Okay, a little bit more. Okay, once you are done, you can click on serial monitor, and you are able to see what's happening here. So what's happening that it will tell you that it will start in 2 seconds. When the word sampling appears, you can press the button and they will tell you what is the results of it. Okay. So in my case, the short press is doing a good job, and the long press is not doing a good job. It is barely doing a pass here. Okay. So that is because of the model itself. So congratulations, you have created a simple machine learning uh, model and implemented on the edge itself, meaning that this MSP432, the model is within the MSP432 and is running on the board itself. and is able to do inferencing on the board at a very low, requiring only low resources and reasonable amount of time, see, within 1 milliseconds, and you don't need to couple it with the internet. So this is, for lack of a better word, you have just implemented edge computing. Congratulations, then. So that is all for this lab, and I hope that you are able to use other means or other data together with the machine learning model to do more interesting things. Okay, with that, thank you very much.